Hello class, sorry I couldn't make it today. My kid is at home very sick, so I'm going to stay home and take care of him today. I want to go through a couple notes with you and then give you kind of the end of class today where you can actually take some time, work on some other homework that you may owe some other classes. I'm not going to use the entire class today, but I feel that you could probably use a little bit of time off from doing homework. We've done quite a bit lately. But let's go through just a few things because I don't want to waste today. I actually want to get a little bit of notes in before I get and give you some time at the very end of class. Yesterday we introduced the transformations, as you can see here. We introduced what a translation was. That is a slide, if you will. We introduced what a reflection is. It's kind of like flipping a picture. We introduced what a dilation is, or dilation. It's to grow or shrink an object. And we talked about that today we're going to do clockwise rotation. We are going to try to rotate clockwise or counterclockwise on a graph. That's one I want to cover today. So hopefully that makes sense to you. So that's kind of our goal today. Now, the order of transformations that we discussed yesterday, this is where you mix multiple transformations together. Let's say you're going to slide, flip, grow, or shrink. This is the order we go in. Now, yesterday I kind of hinted at the fact that I didn't put rotation in the list. The reason why is that I looked through most of my notes I had in college and other places, and there's a reason why rotation's not in the list is because rotation, you actually rotate over coordinates. It's not a part of the normal order of transformations that you do on a function. So if we had coordinates on our graph, we could rotate them later. It could be at any point in the graph. So I'll fill you in on more of that later. For right now, let's do a couple examples of actually translations. I'm going to go, let's do a translation where we go left and right, or up and down. We'll do one of each. Then we'll try to talk about shrinking and growing an object. I'll try to do maybe an example of maybe shrinking. That's dilation. And then we'll do an example of a reflection. What I want to end with is an example of rotation, and we'll kind of go through that example. But I'm going to give you a graph here. Hopefully you have the graph paper that I provided you yesterday. If you don't, there's some over by the calculators by my marker board. If you want to grab some now, take your time, do that. But let's go through and talk about translations. Left, right, up, down. So let me give you an original graph here. I'm going to try to put this in a unique color so hopefully you can see this. Let's put some dots on this coordinate. Let's go 4, -2. Let's go with 1, 2, or -1, 2, I should say. 1, 2, and 3, -1. And it's kind of mimicking the picture we did yesterday, but I'm going to connect these with lines. So let me draw the lines connecting these. I'm going to make it a little bit thin. Let's connect these with a line going across and down. Okay, so there's my graph. Let's work with this and let's translate this to the left. So if this is my original function, so let's call this as f of x. Well, how we're going to shift this to the left is we're going to take my function and actually throw in a number like this. We're going to add a number on the inside. So if like we want to move it to the left 1 space, we add 1 here. You add 1 and it moves it to the left. I know that seems really odd. It seems almost counterintuitive what you think, but it's replacing the new 0. That the new origin would actually be a -1 now, because these would add to make 0 the new origin. So that's the purpose behind it. We can do any type of number you want, but hopefully that makes sense. So we're going to move this picture to the left 1 spot. Well, when you have that, you just basically take each coordinate and you move it to the left once. So this coordinate here will move over to the left here. This coordinate will move over to the left. This coordinate will move over to the left. And this coordinate will move over to the left. And so now we have a brand new graph. And let's graph this now. So I'm going to go up, over, and down. And there's my graph. It's shifted. It's a mirror shift in the graph. That's a translation. It's sliding. It's I think the example I used yesterday in class was if you're going to play the game of Battleship. The game of Battleship doesn't allow the boats to actually go diagonal. You can only go up and down, right and left. Well, that's what we're doing. We're translating. We can move the boats around, but we can't actually rotate the boats. It's not possible. So that's a type of translation. Now, if we wanted to go up with this function, the idea is that, let's say we wanted to go, maybe we want to go up 2. So if this is my graph, let's say I did the left translation there, and I want to shift this thing up to a vertical shift, what we would do is we'd add a number in the back. And notice it's not an opposite. Actually, adding a 2 behind the parenthesis will actually take this function and shift it up. That's the idea. Okay, so each coordinate will be now shifted up to, and I'm going to go off of the one I just did. So on the light blue one here, each dot will be moved up 2 spots. And so this is my new picture from the original. Very, very different. So hopefully this makes sense of how the translation works. So that was a check on that one. So we're done with that. We'll move on. We're going to move on to the other types. So let's do shrinking now. So a type of dilation, and we'll do reflection later. But let's try that out. So I'm going to go off the original picture again. So I'll redraw the original picture. Let's get rid of some of my marks here on this graph. All right, so now we're going to do dilation. We're going to try to shrink the object. So I'm going to go off the original picture and go back to what we had earlier. It was something like this. Again, I know this is not the exact graph, but you get the idea. Okay, so there's my graph, and we're going to shrink this object. So we'll do a horizontal shrink first. So that's when I take my function. Let's go in here and let's modify this. So I'm going to take my function and I'm going to put in a number like, let's say 2 in here, like a 2x. I think that was a number that we did yesterday. Well, this will shrink the object. I know it's counterintuitive again, but anytime you throw a number inside the parenthesis, it does basically an opposite of what you think it would. So what we discussed yesterday is that when you do this, it's basically going to allow 2 full pictures in this picture frame. So in that picture frame, it'll allow 2 of the original pictures to kind of fit. That's the idea of what we're doing here. Let's take each of these numbers, and basically what's happening is over the origin, these numbers are shrinking half in size and width. So if it's 3, it's now 1.5. That's half of it. If it's 1, it's now 0.5. If it's 2, it's now 1. If it's 4, it's now 2. And this is what the picture looks like. It's half the size. So I could fit basically 2 of those pictures in there. Now, if I want to do a vertical shrink, now that function is now modifying them. Instead of putting a 2 on the outside, it's going to now put a half on the outside. We're going to go half as tall. That's shrinking the object vertically when it's on the outside. The same with like when we translated up and down. The number was on the outside. And it's not counterintuitive. It's exactly what it looks like. So each of these dots now are going to be half as tall vertically. So if it's 1, it's now, or -1, it's now -half. 1 is now -half. If it's 2, it's now 1. It's 2, it's now 1. And we can draw the picture. It's not being pressured horizontally. It's just pressured vertically. And that's the idea with the dilation. So hopefully that makes sense. So numbers on the outside, it's exactly what they look like. Number on the inside is kind of counterintuitive. We talked about, if you want to grow the objects, the numbers you can put. We did a couple examples of that yesterday. When I'm back on Thursday, we'll discuss that a little more. But that's the dilation, so we'll check that one off. We'll move on and let's do reflection now. So let's get rid of all my graphs here. All right, let's get rid of that. Okay, so we're now going to reflect this object. Let's reflect it across maybe the x-axis. So I'll kind of make up a kind of a different looking graph here. So let's go with something like 3, 1, 1, 2, 4, and 1, 5. So we'll go up straight, and then we'll kind of make a little loop going up. There we go. Okay, so now what we're going to do is we're going to reflect this thing across the x-axis. So what we talked about yesterday is to reflect this original function, so this is my f of x, to reflect it across the x-axis, what we're going to do is we're going to throw a negative sign outside. And what that'll do is it will flip the graph completely across the x-axis. So if any of these coordinates are on the top, they're now going down below the x-axis. And if they're below, they're now coming up at the exact same number. It's not going to change horizontally or vertically. It's just the dots themselves jump across the x-axis because basically every value is now becoming the exact opposite. That's what we're doing. Okay? All right. So let's continue here. So how we're going to do this with this type of reflection, since this is 3 up, it is now 3 down. If this is 2 up, it's now 2 down. 1 up, it's now 1 down. And same with those. And then the last one was 1 down, so now it's 1 up, and I can draw the picture. And so it is a perfect reflection across the x-axis. And again, now if we throw the negative sign on the inside in here, now it's going across the y-axis. So this picture would actually move over this direction. Okay, hopefully that made sense to you. Those are the types of reflections. Now let's go over rotations. This is the new one. This is one we haven't seen before, so we're going to take our time. I'm actually going to draw kind of a shape here, and we're going to actually rotate it. And you can kind of see what direction it's going to go, and I'll give you the kind of the tools that we're going to use here. Okay, so let's start completely fresh. So let's erase all the graphs here. Okay, so we're going to start with an original f of x. So I'll draw some type of picture here. Let's go with here, here, here. Let's go across and down. All right, so this is my graph. There we go. So it's kind of an odd looking graph, but we're going to rotate it. So now how we do a rotation is you have to look at each coordinate. So on the original graph, these are my coordinates, right? They're x, y, it's called an ordered pair. We can actually write down what the coordinates are. If I'm going left to right, one of the coordinates was -4, -1. The coordinate going to the right was -2, 3. The next coordinate was 1, 3. And the last two coordinates are 2, 2, 5 and 3, 4. Okay, so there's my coordinates, right? All 5 that make this graph. Now, to do a rotation, basically we have a formula that will do it for us, which is really, really nice. So the formula, how we're going to do this, is you're going to flip the 2 coordinates around, and you're going to make the first one negative, like opposite, basically. So if we flip the coordinates around, so the first coordinate we had was -4, -1. We're going to flip the 2 coordinates around and make the first one an opposite. So now it's 1, -4. And let's keep going through the pattern here and doing every coordinate. So we're going to flip the 2 coordinates around, make the first one opposite, flip the 2 coordinates around, make the first one opposite, flip the 2 coordinates around, make the first one opposite, and flip the last one around and make the first one opposite. And we're gonna graph these 5 dots now, and you can kind of see what's going to happen with the graph. So let's go here. So on the original graph, it's 1, -4. 1, 2, 3, 4. -3, -2, -3, -1. Is that right? Or -3, -1. Sorry. Let's erase that. -5 up 2 and -4 up 3. And so here's my graph. And so what happened here is that this graph actually rotated counterclockwise. So it's a counterclockwise rotation. That's one type of rotation that we have. Now, what type of clockwise rotation it's actually doing? It's actually doing a perfect 90-degree rotation. So 90 degrees is a perfect L shape. So in fact, if I mark this and kind of show you here, it's actually rotating this direction 90 degrees. So imagine that this is the middle of a stereo knob. So here's your stereo knob, right? And you're going to turn the knob, so you're going to turn the volume down. And this was a sticker on the actual object, the red object. Well, when it turns, the sticker doesn't change size, it's just changing location. So this is the center of the graph, or center of the knob. When you rotate it, now it's rotating 90 degrees. That's the idea. Okay? Now, if you wanted to go clockwise instead of counterclockwise, basically the only difference is when you switch the two coordinates around, you'd make the first one negative. That'd be the only difference. Or I guess when you switch them, you'd make the second number negative, I guess, from the original. Okay, from the original graph. And that would rotate clockwise. That's the idea. Okay, questions, comments about any of that? Again, I'll be back on Thursday to answer questions. So hopefully it makes sense. You get to see it for the first time. Now, that's not the only type of rotation we can do. There's, the counterclockwise rotation. There's the clockwise, which is this one I was trying to explain how you can do that on the original coordinates. And then there's another type of rotation is a 180-degree rotation. So let's get rid of this. And a 180-degree rotation, again, this one doesn't matter if it's counterclockwise or clockwise. 180 is just spinning all the way around. That is where the coordinates actually become both negative. You keep them exactly the same way, but you just make them both the opposites. And that will rotate the picture completely 180 degrees. In fact, what it's actually doing, and this is kind of the cool part, it's actually doing a 90-degree rotation counterclockwise and then doing it again. So, and the idea is that when you do the 90-degree rotation, you can see the two coordinates flip and the first one becomes negative. And then when you do it again, the two coordinates flip locations. So the negative y went to the back, the x went to the front, and then you made the front item negative again. So it's doing two 90-degree counter rotations. So you can actually see the formula did work. We're going to look at that one probably tomorrow. But these are all the different types of transformations. I want to show you that. Now remember, we do have an order for how this works. The order is being covered up by all my notes here. Let's go back to my original thing here. All right. So the order here is when you have multiple types of transformations, you have to do horizontal shifting first, the actual translation, so either right or left. Then you would shrink and dilate this thing either vertically or horizontally. Then you do some type of reflection, either y-axis or x-axis. Then you do vertical shifting last. That's the order that most colleges and math classes always follow. That way everyone gets the same graph and everything looks correct. Because if you went out of order, these graphs could be radically different, because if you're growing and shrinking after you rotate it, or reflect it, well, then the graph could be very, very far away from the original picture, especially because when you stretch, you could be 2-3 times away from the origin. Well, that affects it if you're rotating it or reflecting it or translating it. That could affect the number. That's why they always wait to do translations until later. Hopefully this made sense to you. Again, your homework that was due yesterday, make sure you have that turned in. That was the page 188 and 200. Make sure you get those turned in if you haven't already, if you're gone. But I'll be back Thursday. Enjoy the rest of your class period. Hopefully you learned a little bit about the different types of transformations and you feel a little more comfortable. Again, we'll continue this lesson on Thursday, and we'll get homework on Thursday, so bring your textbooks. Okay, enjoy your day. Sorry I couldn't be here, but I will be here for parent-teacher conferences tonight if your parents want to be there. Have a great day.